Hello everyone, in this video let us solve this question. So we have 27 raised to power x minus 9x and this equals 0. And here, what to solve for the value of x. To solve this, solution. So we have 27 raised to power x minus 9x and this equals 0. And by the way, we're going to use two methods to solve this given problem. So for the first method 1, okay. Now, first thing first, move minus 9x over to this side, 27 raised to power x, and this equals 9x. Then, divide this equation by 27 raised to power x, 27 raised to power x. This, we divide this, we have 1 equals 9x over 27 raised to power x. At this junction, making use of this rule of indices, that if you have 1 over a raised to power n, this equals a raised to power minus n. So applying it right here, 1 is equal to 9x times 27 raised to power minus x. Then divide this equation by 9. So now we divide 9. What we have is we have 1 over 9 equals x times 27 raised to power minus x. Now, at this junction, we're going to move this to the left-hand side and move 1 over 9 to the right-hand side. This then becomes x times 27 raised to power minus x equals 1 over 9. Now, we're going to apply the Lambert-W function to the left-hand side of the equation. So if you have a times e raised to power a and you apply the Lambert-W function, this equals a. In this expression right here, you'll notice that a is equal to the power a right here. But in this case, we have x, which is not equal to the power minus x. So to do so, multiply this equation with minus 1. So we have minus 1 into bracket x times 27 raised to power minus x, and this equals 1 over 9 multiplied by minus 1. Multiplying this, we have minus x times 27 raised to power minus x. This equals 1 over 9 times minus 1. Now, at this junction, you notice that e is in the expression. So, to then introduce e, we're going to make use of this function that if you have e raised to power ln a, this equals a. So, following this rule, if you have e raised to power ln 27, this equals 27. So, in place of 27 right here, we bring in e raised to power ln 27. And from this, we have minus x times e raised to power ln 27, then all raised to power minus x is equals 1 over 9 times minus 1. And making use of this rule of indices, that if you have a raised to power b, all raised to power c, this equals a raised to power b times c. Applying this rule right here, we then have minus x, then times e raised to power minus x ln 27, and this equals 1 over 9 times minus 1. But then recall that from the Lambert-W function, if you have a times e raised to power a, this equals to a. But in this case, the value right here must equal the power right here. Now looking at this, the value right here minus x is not equal to the power right here. So to do so, multiply this equation with ln 27. This then becomes ln 27 multiplied by minus x times e raised to power minus x ln 27, and this equals 1 over 9 times minus 1 times ln 27. Multiplying this, we have minus x ln 27 times e raised to power minus x ln 27. This equals 1 over 9 times minus 1 times ln 27. So at this junction, we can make use of the Lambert-W function to the left-hand side of the equation. But before then, let us simplify the right-hand side of the equation. First, we're going to make use of this rule that if you have m times ln a, this equals ln a raised to power m. So applying this rule right here, this then becomes equals to 1 over 9 times ln 27 raised to power minus 1. Next, following this rule of indices, that if you have a raised to power minus n is equals 1 over a raised to power n. This is then equal to 1 over 9 times ln 1 over 27. And with this, we can express this as this is equal to 1 over 9 times ln 1 over 27 can be written as in brackets 1 over 3, then all raised to power 3. Next, this is equal to 1 over 9 times, following this rule that if you have ln a raised to power b is equals b times ln a. Applying this rule right here, power 3 then becomes 3 times ln in brackets 1 over 3. But then recall that this is equal to the left hand side minus x ln 27 times e raised to power minus x ln 27. So what we have is this, that minus x times ln 27 times e raised to power minus x ln 27. This is the left hand side equals the right hand side 1 over 9 times 3 times ln 1 over 3. Next, 3 will divide 9, we have 3, and this is then equal to minus x ln 27 times e raised to power minus x ln 27, and this equals 1 over 3, then multiplied by ln 1 over 3. At this junction, we are then going to apply the Lambert W function to the right hand side of the equation. So if you have an expression like a times e raised to power a, and you apply the Lambert W function, this is equal to a. Now, looking at the Lambert W function, we have a in this expression, so we need to introduce e into this equation. And to do so, if you have e raised to power ln a, this equals to a. So also, if you have e raised to power ln 1 over 3, this equals 1 over 3. That means that in replace of 1 over 3 right here, we'll bring in e raised to power ln 1 over 3, such that what we have as this equation, this then becomes, we have minus x, then times ln 27 times e raised to power minus x ln 27, and this equals, in replace of 1 over 3, this then becomes e raised to power ln 1 over 3, then multiplied by ln 1 over 3. Also, looking at the Lambert W function, you will notice that e is in the second place, but right here e is in the first place. So move this e to stay in the second place. This equation then becomes, we have minus x ln 27 times e raised to power minus x ln 27, and this equals ln 1 over 3, then times e raised to power ln, we have 1 over 3 raised to power 1 over 3. So from here, we can then apply the Lambert W function. So once you apply the Lambert W function to this expression right here, okay, what we have for this then becomes minus x ln 27, and this becomes ln 1 over 3. Okay, also making use of this rule of indices, that if you have 1 over a, this equals a raised to power minus 1. So applying this rule right here, we have minus x ln 27 is equals ln 3 raised to power minus 1. Next, minus x ln 27 can be written as 3 raised to power 3 equals ln 3 raised to power minus 1. Then making use of this rule, that if you have ln a raised to power b, this equals b times ln a. Applying this rule right here, so this equation then becomes power 3, then becomes minus 3, then multiplied by x, then times ln 3, and this equals power minus 1 comes to this side, this becomes minus 1 times ln 3. And with this, minus cancels minus, we have 3x ln 3, and this equals ln 3. Then divide this equation by ln 3, okay, ln 3 will divide ln 3, we have 3x equals, this divide this, we have 1. Then divide this equation by 3 to solve for x. 3 divide 3, we then have the solution of x, that x is then equal to 1 over 3, and this is the final solution for the value of x for the first method. Now, for the second method, right here, for the second method method 2, we have the equation 27 raised to power x minus 9x, and this equals 0. Move minus 9x over to this side. This becomes 27 raised to power x equals 9x. Then we're going to divide this equation by x, x will divide x. We have 27 raised to power x equals 9, and this is being divided by x. Next, we can solve this as 27 raised to power x divided by x, and this equals 9 can be written as 3 times 3 times 1. And from here, we have 27 raised to power x divided by x, and this equals 3 times 3 times. So we can write down 1. 1 can be written as 1 over 3 divided by 1 over 3. So this one right here will be written as this. So we have 1 over 3 divided by 1 over 3. Okay, so solving this, we have from here 27 raised to power x divided by x. This equals 3. We cancel this 3. We have 3 divided by 1 over 3. And from here, this 3 has a power of 1. And we can write this power 1. This 1 can be written as 3 times 1 over 3. So this then becomes 27 raised to power x divided by x, and this equals 3 raised to power 1 which is this, 3 times 1 over 3, then divided by 1 over 3. Applying this rule of indices, that if you have a raised to power b times c, this equals in brackets a raised to power b all raised to power c. Applying this rule right here, this then becomes 27 raised to power x divided by x, and this equals 3 raised to power 3, okay, all raised to power 1 over 3 divided by 1 over 3. And from here, we can write down 27 as 3 raised to power 3, then all raised to power x divided by x, and this equals in brackets 3 raised to power 3 all raised to power 1 over 3 divided by 1 over 3. Now, looking at this equation, by comparing it, 3 equal 3, x equal 1 over 3, 3 equal 3, x equal 1 over 3. So with this, the solution of x is equal to 1 over 3 by comparing this equation. So this is the value of x equals 1 over 3 as the final solution to the given question. I hope you all enjoyed the video. Do well to like this video, subscribe to this channel. Thanks for watching. God bless you.